Hello all and welcome back to my YouTube channel. I hope you guys are doing really great. So welcome to the yet another video where we are learning a AutoGen project where we are going to build a legal RAG assistant and we are going to build this project from very scratch. And this is going to be the implementation of whatever we have studied till date. So as you all know that we have covered a AutoGen playlist and we have covered everything starting from very scratch, building two agent framework to the multi-agent framework. And if you have missed that particular playlist, I would highly recommend go ahead and check out that. So this project is also going to be the part of the same playlist. So let me show you the playlist. Yeah, so if you can see this, initially we started with a simple AutoGen introduction. Then we have seen the different conversations, how we can handle the termination methods in AutoGen. Also, we have seen how we can add a human in the loop interruptions. We have seen interruption methods. Then we have seen a couple of very interesting examples. Then we switched to building a smart multi-agent frameworks. Also, then we have studied how we can add a code execution functionality for AutoGens. Then we have seen how we can register tools in the AutoGen to empower the AutoGen agents. Also, we have seen a couple of good examples. Then we have seen the different conversation patterns. So if you have missed this particular playlist, I would highly recommend go ahead and check out that playlist. The link is already available in the description below. Okay, so without wasting time, let's switch to the today's agenda. So where we will be building this particular project that you are seeing on my screen currently. We will be building a legal RAG assistant, and this is going to be the small project where we will be uploading a legal documents to the application, and then the application with the help of RAG will extract that particular content from the document, and then user can ask multiple questions. So the use case is very similar to the real-time use cases in the organization, because let's say if you have 100-page documents and you want to get or you want to extract some information from that, so it's not possible for you to go through the 100 documents. It is not feasible for you to quickly go through the 100 documents and then 100-page documents and memorize those things and get your question answered. So instead, right, what we can do is we can upload that document to our application. Our application will extract the content, and then with the help of LLM powered agents that will extract the required information for you from that particular document. And that's the real use case that we are solving. So you can extend this particular use case for other use cases as well. Here we are specifically focusing on legal RAG assistant, but most part of the code will remain same. If you want to, let's say, switch to the medical implementation, let's say if you want to extract some information from medical document, you just need to change the prompts for agents, and at time to time whenever we are writing the code, I will be helping you where you can exactly change in order to change this use case to your another multiple use cases. And that's where we have tried to build a basic framework that you can reuse for multiple other projects. So let me give you a quick demo of application. So you can see this is the interface that we have built, and we have built this interface using Streamlit application. If you really want to deploy such applications, either you can go ahead with the fast APIs, and then you can build the user interface with the help of React, and then you can deploy the applications. For the demo purpose, I have just used Streamlit, and that's where I have not much decorated the user interface. But yeah, as you can see, we have a title above. Then here you can see what it does is we can upload our legal documents and ask legal questions, and our AI assistant will respond with contextual answers extracted directly from the document. So as we know that LLM are trained on a global data that is available, and it's difficult for us for that particular LLM to train on our custom data, and that's where RAG is one of the tools that we can use in order to request or in order to use the functionality of LLM to extract some information from our custom documents, and that's what exactly we have done here. So you can see here we have a browse file options where we can browse the legal document. So let me show you. This is the sample rent agreement that we will be uploading. It's nothing but a very simple rent agreement, and there multiple information is available. So we can upload that particular rent agreement document, and as you can see, once we have uploaded, the PDF is uploaded successfully, and you can see building FAISS index from uploaded PDF. So we have used FAISS index in order to embed and generate the vector store out of that. So FAISS is nothing but Facebook AI similarity library that we have used. and we'll see everything in the depth. So you can see index built and ready to go. So whatever file we have uploaded, it is now stored into the vector store, and now we can ask our questions. So let's say we can ask simple question: can I have a pet in the apartment? Okay, so you can see we have asked this particular question: can I have a pet in the apartment? And this is retrieving the answer from legal assistant. So this particular query is embedded, and that's how it is searching it into the vector store. It will extract first 3 records from the vector store. That's what we have given, and then based on that, it will pass that information back to the agent, and agent will retrieve the answers for us. So you can see pets are allowed in the apartment only with the landlord's written permission, and when you are moving in, only pets listed on the rental application are permitted. There is extra pet rent charge of rupees $25 per month. So you can see, right, this is how it is extracting. And you can upload any of your legal document, and you can ask questions on top of that if you have any, and that is what we are going to build. So isn't it interesting? So without wasting time, right, let's jump in and see how exactly we can build this particular project. So just to make it clear, we are going to build we are going to study architecture first, the logical flow of the application, and then we'll start the coding. So before jumping into the coding part, let me just show you how exactly the flow works, how the agent communication is working, and what are the technologies that we are used to underline this particular project. Okay. As you can see now, what we have is, this is the particular thing that we have seen on the application now. This is the legal assistant tab that we have seen, where user is uploading a document and then asking a question. So from here the flow starts. So whenever user is uploading a document, let's say the legal document PDF user has uploaded, the first module that we are going to build is the RAG index builder. So this RAG index builder is nothing but it is going to take the document that we have uploaded and embed that particular document. So first, this legal document, we will be having a text extraction. So we will be using a PyMuPDF tool. So we'll be using a PyMuPDF tool in order to extract the text. And once the text is extracted, we will be using a FAISS library. FAISS is nothing but the Facebook AI similarity library. It's a AI similarity library which helps us to generate a vector store, helps us to generate a vector embedding. So basically it will generate the embedding plus indexing. So embedding is nothing but converting your text into numerical format, like the number format, and indexing is nothing but storing those records in index space so that it is easy for retrieval. And then we will be storing it into the FAISSDB. So FAISSDB is nothing but the local DB file that we will be creating, and we will be storing all our this embedded data into that local DB. So this later on we can replace it with any vector store database, like you can use ChromaDB, or we can use Pinecone, or we can use Azure AI search. Those are the things that are available. Apart from that, there are many more, but we can use these. So for now, for the simplicity purpose, we have stored it. We will be storing it into the local DB file, and from there, we will use that particular local DB to extract the details. So that first loop is completed now. Whenever user is uploading the document, it will be stored into the FAISSDB. Once that part is done, so that's what the RAG builder we will be building, and we'll see each modules and we'll execute each module to see what exactly is happening behind the scene. Then users are asking the questions. So here we have asked the questions about pet, whether the pets are allowed or not. So that questions first will go to this particular agentic framework that we are building, AutoGen agentic framework. So we are building 2 agents. First one is the user proxy agent, and second one is the legal assistant agent. So user proxy agent is nothing but this agent will act as a proxy of user. So whatever, let's say, code execution needs to do, any human related task that needs to be done, that is done by user proxy. So it will act on behalf of human. In our case, it is going to be executing this retrieval tool function that we have written. So what it will do is, first questions goes to the user proxy. User proxy will ask that questions to legal assistant, that okay, whether pets are allowed or not. So what legal assistant will say that, oh, okay, I have ability to retrieve the information from legal document. This is the tool that I want to use. Could you please go ahead and execute that particular tool? that instructions it will give to the user proxy. User proxy will say, okay, I know how to execute that particular tool. I will execute that tool. So this particular user will take this particular paid question. So legal assistant will modify that questions. It will just refine that particular question and hand it over to user. User will pass that questions to this particular retrieval tool. This retrieval tool, what it will do, it will extract the top 3 matching records from the database that we have created, vector store that we have created. And that retrieve information, user proxy agent will pass it to the legal assistant again. And then this legal assistant will read that particular response, and accordingly, based on the user question, it will generate the final response. So in the top 3 matching records, there might be the information related to the pet, it might be related to the rent, and many more, right? Because top 3 matching records, it can be related to pet, and apart from that, it can be anything that is the closest match to pet. And then this legal assistant will extract only pet related information from that, and then it will hand over that response, final response, back to the user. So that results will be showcased to the user. So that's how the complete flow will work. And we are going to build each and every piece. So those 4 pieces, right? This is the first piece where we will be building a user interface. So first of all, we'll build this particular part, RAG index builder. Then we'll build the retrieval tool. Then we'll add a agent functionality, and at the last we will building a user interface. So that's how the complete project is all about. I hope this logical diagram is clear to you. If you have any questions, feel free to comment down your question. I will definitely look into that and I'll try to answer the questions. So it is very straightforward. So let's not get confused. If there is any confusion, or if you want me to elaborate any topic, please let me know. So without wasting time, let's jump into the coding and I will start writing the code. Okay, so I have opened our Visual Studio, and this is the folder that we'll be using, Legal RAG Assistant. So the first step in every project is to create a virtual environment. So let's go ahead and create that. Let me open the terminal and let me switch to command prompt. So I'll be using Python 3.13. That's the latest version that is available. But yeah, if you don't have 3.13 installed, you can work with your environment. But please make sure that the version should be greater than 3.9 or 3.10 at least. Okay, so let's create the virtual environment. UI 3.13 -m venv my env. So either you can use this command, or if you don't sure about the Python environment, then you can directly use Python -m venv and the environment name. So our environment name is my env. So let's wait for the environment creation. Okay, you can see the environment is created. You can see the folder here. And in order to activate the environment, we need to use this particular file, activate. So let's go to that file, my env. It's under script. We have activate. So you can see the environment is activated. Now let's go ahead and create the requirements.txt. So in the requirements.txt, let me add a few common dependencies. So at the end, I'll be pushing exact dependencies. I'll create a requirement.txt and I'll push it. So to get started with, let me write some dependencies like OpenAI, LangChain and AutoGen. And let's go ahead and install the dependencies. Pip install -r requirements.txt. Okay, meanwhile, the requirements are getting installed. What we can do, we can go ahead and create some required files. So what we will need is, we will need a .environment file as well. So let's create that. And also, as we discussed, the first model that we'll be building is this RAG index builder. So let's get started with RAG index builder. So let's create that file, RAG index builder.py. And let's import some dependencies. Like we will need a feeds is nothing but the PyMuPDF dependency. This feeds library is useful for extracting the text from PDF. And oh yes, we'll import the dependencies as we go ahead. Okay, then we can start writing the code now. So the first function that we will be writing is, we need to build the index from PDF. So let me write that. Okay, so we'll be using build index from PDF, and here we need to pass PDF path, and again that path is in string format, and then we will be using persist directory. So this is the path where we will be storing the local database. Once the vector embeddings are generated, we will be storing that at this particular persist directory. So this directory, again, it is in the form of string, and let's pass the custom path. It's going to be at the root folder, and we can add this, we can create this particular folder. So this is going to our FAISS store. And as I mentioned, FAISS store is nothing but it is a local storage, local database file that we will be creating. Okay, so let's start writing the code now. So first of all, what we need to do is we need to extract the full text. And to extract the full text, we'll be using a extract text. We'll write a custom function, extract text from PDF, in order to extract the text. So for that, we need to pass the PDF path. So let's write this particular function first. And we need to pass PDF path to this particular function. And again, this path is going to be in string format. And okay, so let me write that function. So we'll be using this feeds library in order to open the PDF from this particular path. Then we'll be collecting everything, the full text into this text. We'll be iterating page by page from the documents available in the PDF, and then we'll be getting the text. So we'll be using this function in order to extract the text. So this will return full text. So let's go ahead and check this. So in order to test this code, let's write a main function. So with the help of this main function, we'll be able to test. And let's call this build index from PDF. And we need to pass this particular PDF path. So first of all, let's create the PDF path here. So let me create a docs folder, and inside that, let me paste that particular PDF, and I'll come back. Okay, so I have added the document here. So this is our document, sample rent. So let me copy the path, and we can pass that particular path here. We no need to pass the complete path. So let me remove that. Instead, we can use the path from the current location. Okay, so let's see whether it is returning the full text or not. So let me just go ahead and print this particular text. Okay, so let's execute the file. Okay, feeds is not defined. So let's go ahead and install feeds. Let me go ahead and run the requirements.txt. Meanwhile, let me show you how exactly this particular PDF looks like. Okay, so you can see this is the sample rent agreement where the agreement date is mentioned. Several clauses are mentioned, like about the rent, about the method of payment, the payment procedure, other clause like security deposit, cleaning fee, all those details are mentioned, notifications of serious building problems regarding pets, and the disclosure. So this is the document, rent document. Okay, so the dependency is actually PyMuPDF, not feeds. Sorry, my bad. So we have installed the PyMuPDF. So let's go ahead and run this particular code now. Python rag builder.py. Okay, you can see it has extracted the document, all the information it has extracted. So that's the full text, right? So you can see it is starting with this particular agreement made on this date, and all that information it is extracted. So this code is working fine. Now let's go ahead and build the further module. Now next step is we need to generate the, we need to split the text. So in order to split the text, what we can do is we need to write a text splitter. Now why the text splitter is required? Because if you know that, like whenever we are generating any embedding, we need to split the text, because there are limitations of our LLM in order to if you remember, there is a context length. The LLMs cannot access the sentences longer than the context length, and that's where we need to chunk the text. And that's the standard process in every embedding process. Even while training our LLM models, we need to chunk the text and we need to create the document. So document is nothing but collection of chunk text, and that's what we will be creating now. So first we'll be chunking the text, and then this full text will be chunking into some small chunks, and then with the help of those chunks we'll be creating a document, and that document will generate the embedding. So let's write a text splitter first. This text splitter, we can use recursive text splitter, and this is again from LangChain. The chunk size is 800, so we'll be chunking each sentences into 800 chunk size, and then we'll keep a overlap of 100. So let's say the first chunk is of 800 chunks characters, and then on top of that there will be 100 overlap. So next chunk will have the last 100 characters from the first sentence and then the second sentence. So that's how it will be. So let's import the text recursive splitter. We'll be using this recursive character splitter from LangChain. Also we'll be using document, so in order to generate the document. So let's write the code for document now. So this documents is nothing but we'll be using this text splitter, and then we'll be splitting those documents. We'll be creating this document, and we are passing full text. So that's how the documents are created. So you can see we have used this particular class from LangChain doc store. So let's go ahead and print the documents. Let me show you how exactly it looks like. So let's go ahead and execute the file. Okay, you can see now this is the document that it has created. The complete document, you can see it's a document, and this is the format, page content available in that particular document. See? Okay. So now this is done. Let's move ahead, and now we need to generate the embeddings. So in order to generate the embeddings, what we need is we need a Azure OpenAI. Now there are ways to generate the embeddings. You can use a open source model in order to generate the embeddings. Like you can use Hugging Face libraries to generate the embeddings. What we will be using is we will be using a Azure OpenAI models, and we'll be using a text embedding small model from Azure OpenAI. Now here either you can use Azure OpenAI, or if you want you can use the OpenAI service directly. So for this particular project there are two LLM models that are required. First one is the GPT-4 model that we will be using to give LLM compute power for our agents, and second one text embedding model in order to generate the embeddings. Now the OpenAI embedding works well with OpenAI models. That's where we are keeping the consistency. So let me quickly go ahead and show you how exactly it is done. And I have already covered this in one of the videos, so let me show you that. Okay, so this is the video where I have covered everything related to the Azure OpenAI deployment. So this is the first video of this particular playlist. The link is available in the description below. So go ahead and check out that. So it's basically we have covered how we can create the Azure OpenAI service, and then how we can deploy models. So that part is already covered. Let me go ahead and check out this particular video. So for now, let me go ahead and show you how exactly the model, what are the models that we will be using. So this is the Azure OpenAI service that we have created. Let me log into the Azure AI portal. And in the deployment sections, we will be able to see the deployed model. So as I mentioned, we will be using GPT-4 and text embedding. So this will be used for giving compute power, LLM power for our agents, and this is for generating the embeddings and storing those into the vector store. So that is what we will be using here in the embeddings. So this is going to be the Azure OpenAI embeddings, and let's go ahead and import those embeddings. So we'll be required a FAISS, Facebook AI similarity, in order to generate the vector store, and OpenAI embeddings. Again, we'll be using it from LangChain in order to generate the embeddings. So, but for that particular using those embeddings, we will need to pass the configurations. So to pass the configurations, let's create an environment file. And these are the environment variables that we'll have to use. First, we'll need OpenAI API key, endpoints, versions, the model deployment. So you can see these are the two models that we'll be using. The OpenAI embedding deployment model, text embedding 3 small for embedding, and this is for the agents. So let me show you from where you can grab these details. So whenever you are going into this particular deployed models, so you can click on the model, and this is the key that you can use, and this is the endpoint. So this is your endpoint that will go to this particular endpoint, and here it will go your key. And these details are already here. So if you can see, this is the model version that you can pass, right? So you can grab those details from here, and that way you will be able to consume these models. So now we have added this into the configuration. So let me add these two keys, and then I'll not be able to open the environment file because I don't want to leak my key outside. So I'll pause the video, I'll add those keys, and then I'll come back. Okay, so I have added the keys now. So let's go ahead and use a .env module from Python to load the secrets. So we can use this particular library from .env, import load.env, and this particular load.env will load the all secrets. And let's define those secrets. So we are loading all the Azure OpenAI credentials. First, we'll be using OpenAI API key, endpoint, API version, and embedding model. So that's the model that we'll be using. And let's pass those models into the Azure OpenAI. So in this particular embedding, we'll have to pass that. Okay, so you can see what we'll be using is Azure endpoint we need to define. That's the Azure OpenAI endpoint, API key, API version, and deployment model is embedding deployment model. So that will create the embeddings, and then we need to store those embeddings into the DB. So let's create a DB variable. So we'll be using FAISS library, Facebook AI similarity, and from documents is the class available in that phase. We'll be passing these documents that we have created, and then we'll generate the embeddings. So that document, okay, let's keep it simple. We'll be using these documents because it will confuse with that. So let's keep the variable name as documents, and then let's print the, okay, no need to print the documents. Now the DB is created. Now the next step is to store this particular DB. This code, you can change it to the ChromaDB, PineConeDB, or Azure AI Search, whatever vector stores databases that are available with you. You can use that. For simplicity purpose, we'll be storing it as a DB file. And in order to store that, we'll be using this simple function, simple code. We'll be creating a directory in the persist directory. So this is the persist directory that we have given, and we are giving exit equals to OK. This is in order to override the file if it is available, and then db.save local, we are saving at that particular directory. So let's go ahead and execute that particular code. Let me clear this, and let's execute the file. Okay, so it is saying no module LangChain community. So let's go ahead and add that particular module. Let's install the dependencies again. Okay, so apart from that, we will need python.env. Then we'll need FAISS CPU library. So I have added those and installed the dependencies. So let's go ahead and save the file and run the file again. This should create this particular DB file. So whatever document that is available, it should, for this particular document, it should create the rental agreement. So let's see. Okay, you can see it has created this particular rack FAISS store directory, and there it has added index.FAISS and index.pickle. So this is the indexing in order to easy retrieval, and index.pickle holds the actual vector store data. And this file you can ingest it into any vector stores later on if you want. But now for simplicity, we'll be just reading these local files. Okay. Now we are done with this. So what we can do now is we can start writing the retrieval function. So let me go ahead and create new file. We can call it as, just a sec. Okay, we can call it as tools.py. This file will be using in order to extract or retrieve the data. So as we seen here, retrieval tool, we will be passing a questions. That questions will be embedded, and based on that embedding, it will extract the top 3 match records from the FAISS DB that we have created just now. So let's start working on building the second part. So for that, let's import a few dependencies that are required. So we'll need python.env in order to load the environments. Again, we'll need FAISS and OpenAI embeddings. Now, why these are required? Because whatever user question that user is passing, we need to embed that particular query so that we'll be able to do the vector similarity matching. So for that purpose, we will need these dependencies. So let me go ahead and load the .env. So let's go ahead and start writing the function. So we'll be writing a retrieval legal context. For that, we will be passing a user query that is in string format. Then for that query, we'll be generating the Azure OpenAI embedding. And here we need to pass the same configurations that we have used in the RAG builder. So what we used here is this particular configuration. So we can copy these embeddings. Same things we'll be using here. And again, we need to define these endpoints. So we need to load those from the environment file. So let's add that particular code. Okay. And then again, we can use FAISS model in order to load the local database that we have created. So you can see from FAISS, we are using load local function to load this particular RAG FAISS store. In the RAG FAISS store, we'll be passing embeddings, this particular embeddings, and then allow dangerous deserialization true. So this is just in order to read the complete data. This is the restriction that we have removed. So like whether to allow deserializations of the data which involves loading of a pickle file or not. So because pickle files can modify the malicious actors, and that's where we are giving permissions. As it is in local, we'll have to give it to the true. But whenever we are switching to the actual vector databases, you will be storing that into the database. So you will not need to pass those details here. And then we'll be using a similarity functions from FAISS in order to generate the documents, in order to extract the documents. So you can see from this particular TP, there is a function available, similarity search, where we need to pass the user query and we can give the nearest 3 search. So whatever top 3 queries that are matching to the user query, we are fetching that. And we'll be returning that document. So we'll be returning that document page content. We are just joining them with \n. So that 3 documents are added. Okay, so everything this will go inside the function. And before that, let me print the document and show you whether it is extracting the top 3 records or not. And in order to test that, let me go ahead and write the main function. You know the use of main function, right? If you want to execute any particular .py file, in order to test that, you write main functions at the bottom. That will make sure that this particular code runs only if you are executing this particular file. So if you are using this particular module in another file, it will not execute that code unless you are executing this file. In here, we are writing Python tools.py, right? Then it will make sure it is executing this code. And this helps us in testing the models, individual models that we are building. So first thing is we need to pass the query. So let's pass a simple query. Can the landlord increase rent during the lease period? And then we can use this particular retrieval function in order to fetch the details. And we just need to pass the query. And as it is returning the query, so let's store that into context. And then let's print the context. So retrieve context, we are printing that. So let's go ahead and run this file, see whether it is working or not. Python tools.py. It should return based on this particular question. It should embed that particular query and it should search into the local database that we have created and search the top 3 match records. Okay, so you can see it has extracted the top 3 match records. And the most relevant record, you can see tenants or owners notify the owner party writing at least 30 days prior. They do not wish to, tenant agrees, and all those details are there. I think it's difficult to, yeah, you can see the rent related information is available. So it has matched the query and it has retrieved the top matching records related to the rent. Let's see, he asks questions related to the pet. Are the pets allowed in the property? And let's try this. It should extract the pets related information because that's the RAG operation that we have built now. Okay, you can see it is retrieving the information related to the pets. All the information is related to the pets only. You can see pets are allowed only if that is written in the landlord's. We need to take landlord's permission, written permission before. If we have the landlord's written permission, then only the pets are allowed. And all those information it has given. So this particular part is working fine now. So we have built RAG index and retrieval tool. So half of our project is done now as we have built the 2 models. Now the 2 models are left. We need to build the actual agentic framework and we need to build the UI. So for this particular part now, whatever the response that we have extracted, we need to pass this restruct to the agentic framework so that agent can refine those response and give it back to the user. So out of this, right, that legal assistant agent will analyze this particular response and it will generate only the required response because this is not the correct response, right? These are just the top 3 matched documents. We need to fetch the required information from that. And again, the purpose of RAG operation is to save the token and save the cost. Because if you are passing the complete document to the RAG, right? Like if you have 100-page document, if you are passing complete document, it will take much tokens in order to parse through the documents and then generate the answer based on that. So instead, this RAG operation is useful. Again, it is quicker and also it saves your cost. Now what we need to do is we need to build the agent and also we need to give, we need to register the tool functionality, whatever tool that we have built, so that agents can execute that tool and fetch that information, right? Here we are manually executing the code, but now our agent should execute that and extract the information. So as we have already seen, our user proxy agent will execute this particular code. So let's start writing the agent code now. Okay, so let's get started. We'll be writing the agent code now. So let's create a new file for that. Let's create file as main chat.py. That's fine. And let's start importing the dependencies. So let's import the OS first, and we will need .env in order to load the OpenAI model. In order to load the environments. Now we can start writing the agents. So first we will be writing a legal assistant agent. So in order to write that, let me show you this. So we'll be using a assistant agent. So we'll have to import the assistant agent class from AutoGen. So let's go ahead and import that. Assistant agent we have imported. This is the first agent that we are building and we are giving name as legal assistant, and this is the system prompt, like you are a helpful legal assistant that retrieves relevant clauses from legal document and summarizes the response based on user query, and after answering the user query always responds with terminate to end the chat conversation. So we will be using termination method as is termination flag available or not. Now as this is the agent, we need to pass the LLM configurations as well. As we have seen in our previous videos, we need to give the LLM configurations, and in order to give the LLM configurations, we need to define the LLM configurations first. So let's go ahead and define those LLM configurations, and this is the way we have defined LLM configurations earlier as well. Config list, where we need to pass API key, base URL, API type, API version, and model. Now model is GPT-4 because we are passing the functionality to the agent now, and agent needs the LLM model as GPT-4. We are not using text embedding here because we are not creating any embedding. And in order to load these keys, we can load it from the environment because we are already given. Now OpenAPI version is there, OpenAPI endpoint is there, and API key. Everything we have defined in the environment file here. And then we have built this LLM configuration. So this will load the large language model that is deployed on Azure OpenAI, that is the GPT-4 model, and we'll be able to consume that model. So our first agent is ready, legal assistant agent. Similarly, now we'll have to build the another agent, user proxy agent. So for user proxy agent, again, it is similar to the legal assistant agent. We'll be using user proxy class from AutoGen. So let's go ahead and import that. So from AutoGen, now we are using user proxy agent. This is going to be the proxy user agent. Name is user. LLM configuration is not required for user because user proxy agent does not need LLM capability. It's just going to listen to the legal assistant, their conversations, and it will act on behalf of human. So human input mode is never. Here we need to terminate because this particular legal assistant will send terminate message, and being acting as human, this particular proxy agent needs to take the termination action. So for that we can pass is termination flag or is termination message, and that we can define. So let's write a custom function for that. So let's say this is let's write that particular function here. It is very simple function actually. So we are passing a message. This is the message that will go from this legal assistant with terminate message, and if the terminate is available in that message, then it is sending then it is terminating. So this particular is termination message. If there is any terminate, this will terminate. We are just passing that flag. Okay, so we have built two agents, user proxy agent and the legal assistant agent now. Now what we can do is we can register the tool. Now for these particular agents, we need to add the capability. Currently, these are very common agents now. These agents don't know where exactly the local document is available, how we can retrieve the information from that local document. If I ask questions to these agents, it will give generic answers now. So if you want to test that, let's go ahead and test that. And for testing, right, we can write a main function. And we can start the discussion with user agent. Okay, so let's say we are passing question, can I have a pet in the apartment? Now this agent doesn't know how exactly for which legal document we are talking about. So let me execute and show you. Okay, we need to set Docker as false. Okay, let's do that. So basically, as this is the user proxy agent, it is trying to install code, and we are not it is trying to execute the code, and we don't have any code available. We don't want the user proxy agent to execute the code, and that's where we need to pass this flag, code execution config use Docker false. We have already seen this code execution method in local and in Docker both way, and that is already covered in the playlist. So if you want, you can go ahead and check out. And that's what I mentioned, right? Everything that we are adding into this project is already covered as part of that playlist. So if you are familiar with that playlist, this is going to be the cakewalk for you. So let's go ahead and execute this. Okay, you can see now user is asking questions to the legal assistant. Can I have pet in the apartment? Legal assistant is saying according to the lease agreement, tenants are allowed to have pets in the apartment. However, there are restrictions on type of number and dog. So it is very global answer. In our document, the information is the pets are only allowed if there is written permission of landlord. Plus, there is $25 extra that you need to pay for extra pets. But it is not returning. It is giving generalized answer, right? Now, in order to avoid that, now we need to register several tools so that these proxy agents will go ahead and execute that particular register tools, and it will extract those details from the local database that we have created. So, and that functionality also we have seen in the playlist, how we can register to the tools. But let's see now how we can add the tools. So in order to register that, first of all, we need to add one thing in the tools.py. We need to register the tools. And in order to register that tools, we need to use this particular piece of code where we need to register. This is the class that is available inside AutoGen. And for that, we need to pass these details. So let's add these details. First of all, we need to import the register functions from AutoGen. So let's go ahead and import that. So we'll be using assistant agent and register function, and then we need to pass, this is the retrieve legal context, the function that we have written. Now why it is required? This is the standard format of AutoGen, and it is very easy to register tools in AutoGen. If you are using any another agentic framework, you need to write a lot of code in order to register any function. But AutoGen has already given this particular class register function. You just need to write your custom function. So this is the custom function to retrieve the top three matched queries, right? That is simple Python functions. It will register that function in such a way that the AutoGen agent accepts. So there is specific format that AutoGen agent want the function to be in the form of, and that is what this register function will take care of, converting that into that form. So this is the function that we need to pass. Then caller and executor we need to give. Now for that we need to pass the legal assistant. And legal assistant is nothing but we need to create the assistant agent. That's the function. Who is going to call the function and who is going to execute? We need to define that. And let's define that here. So it's basically again same thing that we have used. You can see caller is nothing but our legal assistant. LLM configurations we need to pass. This is the LLM configuration. It is a simple assistant agent that we have built, right? So this agent is going to call that particular tool. So that is what we have given, and here description is nothing but retrieve relevant legal context from the index legal documents based on the query. Simple description for that particular register function. So that agent knows what is the capability of register function that is given to me. So that's where the description need to be passed. Executor also, here we have given legal assistant. You can give user proxy or you can continue with the legal assistant agent. Both it is fine. So for now, let's keep it both legal assistant, this legal assistant that we have defined here. Now it is done. Now we can go ahead and in main chat, we need to register those tools for our agents. So for registering, it is very simple. We can use this piece of code to register the function. The legal assistant is the one that we have defined here, legal assistant dot register for LLM. That's the class that we are using it from the AutoGen. So let's go ahead and import the retrieval legal context that we have defined in the tools. So from tools, we are using this particular custom function and we need to register that function. So these agents are having this capability. There is function called register for LLM, which is used for registering the tools. And we have already seen that in one of the video. So here we need to pass the name, that is the name of the function. So exact name should match, just like the way we have written the function. The description, what it is doing, retrieve relevant legal document from the index data, and the actual function, that is the tool we need to pass. This way, we are registering the tool with the agent. So we have registered that tool with the legal assistant agent. We can go ahead and register the same for user proxy. So let's go ahead and do that. Okay, so for user dot register for execution, again we are giving the same thing. Now you can see here, with this we are registering or we are giving power to the agents to use the tools, custom tools that we have created. And in our case, custom tool is nothing but this particular function. Very simple function to extract the documents. It is just doing the strings, it is just doing the vector similarity and fetching the required documents from the vector database. Okay, so we are ready now. What we can do is we can go ahead and execute this. Same thing. We can start the initiate chat with user and calling the legal assistant, and we can ask the questions, can I have a pet in the apartment? And now let's see, the answer should be very different. It should be from the document that we have uploaded. So let's go ahead and execute that. Okay, you can see user is asking questions to the legal assistant, can I have a pet in the apartment? Then legal assistant, you can see to the user suggested this tool call. Now legal assistant is saying to the user, oh, this information is available in this particular tool, retrieve legal context. So please go ahead and execute that tool. And you can see executing functions. It has executed that function, and that's how it has given the response for this particular query. This pets in apartment is the query passed by the legal assistant to the user proxy. It has given pets in apartment. So whatever user question was there, it has refined that question and passed so that we can extract the pets related information. And then it has extracted this pets related information, and then it has given that information back to the legal assistant. So user has given this information, this whatever information that it has extracted from the context document that we have given to the legal assistant, and then legal assistant will generate the final response. You can see legal assistant has given to the user, pets are allowed in the apartment only with the landlord's written permission. You must submit a pet application, and again there is a charge of extra $25 per month. Isn't it good now? So our agents are working very fine, like they are talking to each other, they are having a capability to execute the tools, extract the output and refine those outputs and give the final response back to the user. Okay, so that's it. Like we have built the complete project now. Only the UI part is pending, and that is like again optional part. If you are interested, you can like build your own UI. But now, as per this diagram, this third part is also done. So we have almost completed 95% of our project now. We have this user query which is going to the user. User is connecting to the FAISS database, and the agents are connecting to the FAISS database with the help of retrieval tool, fetching the responses and sending back the response to the user. Now we just need to build this particular part on UI to upload the functionality and generate this FAISS DB every time. So currently what we have done is we have executed this RAD index builder manually to create the first FAISS store. But on the UI, right, user can upload any other documents. So whenever user is uploading the document, we need to create that vector store for that user's document. So that part is pending. So almost 90-95% code is done. I hope you are still with me and you are enjoying this particular series. You are enjoying this particular project. And trust me guys, this is a real-time project, so it's not like that something we are building which is useless. I have actually seen such kind of projects that are actually working in the organizations, and I have already seen this is happening in the organizations, and organizations are spending a lot of time in building such applications, AI-based application, and there is huge demand because let's say in the organization, right, there are a lot of organizations data, and if you want to understand that data, you need that data to pass to the LLM models, and that's where, right, your LLM model is not sufficient, or LLM model doesn't know about your organization data because that is your private data. It is not exposed to the LLM models, and that's where you need to feed that data to the LLM models, and that's how the RAG operations are working, and that's how the some projects are going on in the real industries. So it's not only restricted to any IT related organization. It is now I have seen most of the projects in automobile industries as well, where the automobile related documents are getting used are getting fed to the LLM in order to generate some contextual models or chatbots. So this is really cool. I would highly recommend just go through the complete playlist and see this particular project. I'll come up with few more projects if you guys are interested. Just ping me down if you want few more real-time projects. I'll complete those as well. Now let's move without wasting time. Let's move to the last part of the project, that is to build the user interface. Okay, so let's work on the last part where we'll be building a user interface, and as I mentioned earlier, we'll be using a Streamlit library in order to build the user interface. So let me go ahead and create app.py file. Okay, so the requirement for this is we need to install the Streamlit. So let's add, I have added the Streamlit into the requirements and I have already installed that. So let's go ahead and do that. Then in the app.py, let me paste the complete code and then I'll walk you through one by one through each module. So whatever we have written in the main chat.py, we'll be using everything as is. So let me show you. This was just for testing, we have created this. Now for user interface, we need to build another file. So you can see these are the details that we are importing, like Streamlit, obviously, OS. I'll show you this temp file and all. .env in order to load the dependencies. From index builder, we'll be using this index, build index from PDF. So this is the function that we have written in RAG index builder that we'll be using in order to generate the index for new file that we are uploading from the user interface. So wherever this document we are uploading, this legal document, in order to generate that, we need to add that particular code. We'll be using that code, and from tools we'll be using this retrieval legal agent. This is to register the tools. Then from AutoGen we are using assistant agent and user proxy. So this particular code, right, loading environment, loading these details, environment configurations from the environment file, adding the LLM configuration, and this part is termination flag and this legal assistant user proxy agent, and then registering the tools for that. Till this part we have already seen in main chat.py. I have copied the same path, same code here. Just I have given that code into the run agent so that we can run that particular agent whenever we are uploading the file. So that is there, and then instead of chatting and the last part, right, that we have seen where we are starting the initiating the chat, that we have written, we are storing that results into the chat result because we want to print that results at the end. And again, method we are passing here is reflection with LLM. So we have already seen this method in one of the videos, and why it is required, because whenever the agent conversation ends, whatever responses that they are, whenever the agent conversation is going on, in order to pass those responses from one agent to another agent, they need to generate the summary of responses to save the cost, to save the tokens, and that's where this method is used. And also it is helping agents to understand the responses that are generated by each other. So that's what we are passing. And this part I'll show you. This is required in order to extract the last response. Now this Streamlit layout part is there. We are defining this first title, legal RAG assistant. So let me show you this particular part, legal RAG assistant, and adding this particular background, this particular rectangle, and the color coding of that, right? That is what we have given here. So in this particular markdown, we have added that particular background style, the padding, the width of that particular rectangle, and these details like legal rag assistant, the color of that particular, style of that particular, all those information we have added. And again, this ask your legal questions and powered by retrieve augmented generated, this part ask your legal assistant powered by retrieve augmented rag, that part we have defined there. Then next, we have added the markdown to upload your legal documents, this part upload your legal documents and ask questions, this part we have added. Then file upload functionality, we are uploading the file with the help of streamlit.upload file, and here we are uploading the PDF. So this particular part, upload a legal document PDF, this part we are uploading here, drag and drop functionality. So you can see if the file is uploaded and it is not none, again for this file again, that's where we are using this temp file. So the temp file that we are using here, this particular temp file, it is required for Streamlit to load the file. And with this you can see we are allowing only the suffix of .pdf. As per your use case, you can change that later on. You can have CSV, you can have image, whatever you want later on. Then temp file, we are writing upload, we are reading that particular file, and then we are storing that into the temp PDF path. So whatever path that we are passing, this rake phase store, this is the path where we are storing the indexing. So it is giving that path, and you can see it is giving the success method. And then you can see we are adding a spinner. So whenever we are uploading the document, there is one spinner that goes on, and that is the spinner that we have added. And again, this is the query that user will ask. You can see ask legal question, this is the part ask legal question, and then user has the feasibility to enter the question. So this part, that is what we have built here. And then this is the final response which it is generating. Again, we have added spinner, and we have this particular symbol retrieving answer from legal assistant and the agent's answer. So this part, agent's answer part, and then it is giving the final response. And here you can see the chat message, chat history that we are calling, because here we are calling this run agent function. So this run agent, whatever we have defined, it is returning the final conversation, and what it is returning is history, and we need to extract that history. And this is the function that we have written in order to extract the history, because in the agent conversation there is multiple conversation that happen to and fro between two agents, and based on that we need to select the last response that is generated, right? And that is where this particular function will there is a one attribute called get attribute, which is extracting that particular final message. So you can see whenever the role is user and name is legal assistant, the final content it is retrieving from that, and if it is not available, then it is returning no valid answer was generated by the assistant. So that is the final thing that it is returning. You can see if there is no response, then if there is a response, then it is giving final content as well as history. Now this final content is required to show the final response, and the history is required in order to show the historic part. So you can see in expander we are showing the final history. So this is the expander, right, to see final history. That is what we are passing, the full history. And the final response we are this is the final response, agent answer, right? That is what we are generating. So let me show you once again. You can see it is returning final content, that's the final answer, and history, these two, and that is what it is giving. Final history and chart history. This is the final content, and chart history it is using for showing that into the view full context. So very easy code. You can modify this code with the help of ChatGPT or any LLM. Like you can pass this particular code and you can redefine your UI structure. So currently it is in this particular format. You can change these nomenclature as per your project. If you want to change the functionality, if you want to allow another files instead of PDF, you can enable those functionality. If you want to change the structure, you can easily change that, this color coding and everything. Even I have used some AI to just specifically build this particular part. I have used that like to decorate the final UI. So you can use that, you can redefine your own UI. Now as everything is ready, now it's time to test the application, and I am very curious whether it will work or not. So let's try it together. If there are any issues, we'll fix those issues, but Mostly as our main chat.py is working, so we'll not face any issues. But let's go ahead and do that. So in order to run Streamlit application, there is a special command that we need to run, that is Streamlit run and the file name, that is app.py. So let's execute that. Okay, it has started the application. Let's see if it is working or not. You can see it has started at localhost. So let's wait for the application. I think there is some issue. I might not have saved the code. Let me interrupt this. Let me save the code and let's start the app again. Okay, now you can see it is running. I think I missed to save the code. Okay, yeah, it has loaded that. Now you can see this is the final UI and we have options to upload the file. So let's browse it. Let's upload the sample rental agreement. So you can see PDF uploaded successfully, building face index from uploaded PDF. So it's working good. See, it has created the index built and ready to go. And now you can ask the questions. So let's ask any other questions now. Let's ask this particular question. Who pays for the water and garbage bills? So let's see what it is giving. It should dig to the database now, whatever we have created, vector database, and from there it should answer. So you can see it is retrieving answer from legal assistant, and okay, we got the final answer. So the application is working. So the responsibility of paying water and garbage bill typically falls on the owner. We got the answer, right? It is not the responsibility of tenant. Let's ask any another questions. So you can ask your question directly here. Now you don't need to recreate your index. It is one-time activity. You just need to create your index once or vectorized embedding once. Once it is done, then you can keep asking your questions again and again. Okay, you can check out into the legal document. Tenants are required to obtain the owner's permission before parking boats, trailers, utility trailers and all. So that's where you can use garage for storing the trailers. That is the question that we ask and it is giving proper responses. Let's ask one more question. What happens if I pay the rent after the 4th of the month? Let's see. So again, it is retrieving the answers. I think the rent is allowed till 3rd. So let's see what it is saying. If you pay the rent after 4th of the month, you will incur a late fee of 25 plus an additional 5 per day for every day after until the rent is paid. And the rent agreement specifies that excuse such as illness, health issues, financial emergency and all those things. Meaning you can see, right, it has completely extracted the information from the legal document that we have uploaded. So, and here you can see the history as well, how the conversation has happened. Let me show you behind what exactly is happening. So you can see we have asked the question, what happens if I pay the rent after 4th of the month? So user is asking that questions to legal assistant, then it is suggesting to call to that particular tool, and that's how the conversation is happening. And at the last, it is legal assistant is giving the final answer to the user that, okay, if you pay the rent after 4th month, you will be charged extra. So that's how it's working. So I hope it was very interesting session for you and you really like this particular project. And I'm interested to cover more such real-time industrial projects based on AutoGen. Or if you want me to integrate replicate the or if you want me to come up with a new projects in new frameworks, definitely please ping me down in the comment section. So anyway, there is my plan to cover other agentic frameworks as well because as it is in demand. So, and it is very interesting topic. So yeah, that's it. I hope you like this particular video. Please do share this video with your friends. Like the video if you interested. Please ping me down. I'll come up with more videos and subscribe to my YouTube channel. And I'll highly recommend go ahead and watch the remaining playlist if you have missed that. That's it from my side, and thank you so much, and see you soon in the next video. Thank you so much.